Okay, finally got a screen recorder to work. Let's start this, run it through. I'll do this quick. First, setting this up. Geometry is the first thing to do, which is this one. Made a sketch, made a surface. Bam, 0.5 meters tall, 1 meter wide. Made it a little bit on the tall side. If I went back and do this, I'd probably do it 0.25 meters tall to make it more, but there wasn't really a limit on height. Next, mesh. Mesh, skablam, here's the mesh. First thing was select the face, then we set up over the whole face, like a amount of boxes in total, and then to get it to be closer on this side, we set up some edge sizing, and then a reversed edge sizing on that side. That got us the little thin things, turn smoothing off, that's everything. Oh, plus the name selections. Airflow, inlet, outlet, plate, far field pressure. That's what I named the thing up there. Bam. This is setup. Setup. Probably the thing I forgot the most about was setting up the velocity for a while. For a while I had it at 1 meter per second when it was supposed to be 2, and that was in the boundary conditions. Materials, set up the density and viscosity in the fluid. Initialize, ran the calculation. It looks like it's not run right now because I actually X'd out of all this, but we can just run it again. Calculate, did a lot of iterations. Yes. Skablam, scaled residuals, and then using those I would make some graphs and plots. Mostly though, I would do well, there you can see some cool path lines. I don't actually know how to look at those afterwards, but all the graphs I used were in the next section. Yes. Oh, maybe I shouldn't. I don't know. Anyway, this might take a second. Can I pull this down? Skier. Okay. We good? Oh, that looks wacky. Anyway, skablam. Here's the velocity contour plot. This was with the meters per second being 1. It is actually supposed to be 2, but it's just 1 right now. Anyway, skablam, skablam. That's the contour. Here's the vector. Here's the 25 centimeter, 50 centimeter, 75 centimeter. All that jazz. Shear is along this plate, and you can see how the velocity gets lower as it gets close to the bait and interacts with some friction. There's also some charts in here. Those are also visible in other places on the assignment. Here is all together. Look at these beautiful 3. I believe this, what is this? Lowest Y? I think that one's 70, 75? Or maybe that's 25? I don't know. Anyway, shear, skablam. Anything else? Oh yes, exporting. Okay, so once I got these things, I would need to then export. I would just push export right down here. Bam. Put it into my files as a data file. Then with that data file, I would easiest way was to import it into here with from text CSV, and it would give me all the files. Bam, bam, bam. These are actually all look the same because for some reason it prints all of them together sometimes. So if you scroll down here, here's the 50 line, whereas this is the 25 line, and this one doesn't have the 75. And I don't know why it does that, but it does. Anyway, and then I actually just took them from Excel, and then I just pasted them into our Google Doc, which is here. Skablam. Oh, also forgot about printing. Printing that, I think that was done in this screen. Oh, it wouldn't be here yet. Printing. Don't actually remember exactly how I printed the values, but it was in one of these 2 screens. Print, 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 print. What did I do to print? I don't know, it's been a few days since I actually did it because I'm re-recording this. But anyway, I printed it and it should have come out in the console like right here. I just pushed print forces, I think, right? Yeah. And forces was like one of these? Not animations, plots maybe? graphics. I don't know. It was something over here. Reports. Oh yeah, report forces. Skibberlam. Plate. Print. Bam. There we go. Viscous. There's pressure coefficients. Absolutely awesome. That should be all. Okay. Let me end this.